Hello, everyone. I'm here to talk about the SLA 750 and the SLA 750 dual printer. We introduced this machine a couple years ago. This is our flagship production system. This is a great slide to kind of give you a quick overview, and then we'll dive a little bit deeper into some of these advancements and advantages of this platform. To begin with, for those of you guys that already run SLA, our large frame machines have traditionally been around a watt of power at the vat. This machine bumped that power up quite a bit. We have 3 watts of power at the vat using up to 2 4-watt lasers. This gives you much faster draw speeds, and with the ability to have a dual configuration, a dual laser configuration, you can pick up even more drawing speed with this format. We use new hyperscan vector technology. It's just a fancy way of saying we have new scanning algorithms that allow us to draw our vectors more efficiently, and so it becomes really the best in class for vector-based scanning laser system. For those of you guys not familiar with SLA, SLA is the original 3D printing technology. It was actually invented in 1983. We shipped our first machines in 1987. It's called the SLA-1. So this is building on that great technology. It really is still the technology to beat when it comes to building accurate parts in 3D printing. It's really the only non-contact layer additive technology out there. So at no point do we have a roller or a blade or a sweeper or a squeegee or anything making contact with our part as we print. And so that allows us to build very accurate in a semi-buoyant environment. So minimal supports. It really is the technology to beat when it comes to building accurate parts. So based on that, we returned to our roots in some ways with this machine. Simpler frame design, went away from cantilevered recoder, where we actually are running 4 motors to level 2 rails. So our recoder is actually attached at both ends. We still have a removable vat system. This machine is set up to be able to go automated workflow with a robot being able to start and stop prints. We went back to gravity feed for our material. So again, for those of you guys that run SLA, if you've run a large frame SLA machine or even our small frame machines in the last 19 years or so, we utilized peristaltic pumps for moving material. We've gone to gravity feed and then a displacer to displace resin as we print. Resin much quicker. It's a better system, less wear with tubing going through a peristaltic pump. Very nice interface, ability to do remote monitoring, and a machine that's really built to last. So as we go to the next slide, generation large frame machine. It is upgradable to a dual. That dual is going to give you even more speed improvements, up to 3 times throughput on our draw speed, so that drawing time. So when you look at build time with these machines, it's your actual curing time, your drawing time with that UV laser or your 2 UV lasers, and then the layer additive process. So where you're going to see that throughput is that extra speed on draw time because you're utilizing a dual laser system. The dual laser, if you go to the next slide, the dual laser system is unlike what we've done in the past with dual lasers. These 2 lasers can reach everywhere on the platform. So that allows us to not have a seam in our part. So whether you're drawing dozens or hundreds of small parts, or you're drawing 1 large part, you're not going to see a seam anywhere. So we calculate the vectors for each layer, and then those 2 lasers are able to share the duties of drawing those parts. And then 1 laser will be dedicated to drawing the outside vectors of the part so that you don't see a seam where the 2 lasers were stitched in the middle. So that gives us a huge advantage again to building a very nice quality part without having the issue of a seam in the part. The other advantage you have with the dual laser is the ability, if needed, if for some reason one laser needs calibrated or some sort of maintenance done to it, you do have the option to draw just with the one laser, and you're able to still draw anywhere on that build platform. Next slide, please. This is showing you the difference you get in larger throughput. So the machine that this one replaced was the Pro X800. That Pro X800 had a build area of 750 by 650 by 550. This machine squares out that build area to 750 by 750 by 550 V, with also the option to have a short or shallow vat for those of you that are building aligners or shorter parts and don't have the need for that full vat. So that does give you a 15% larger build area than that Pro X800 machine, 100 millimeters wider in that X direction of your build area. And what's interesting is this machine, footprint-wise, ends up being very similar to the machine that replaced. So we became more efficient. We went from a dual frame system to a single frame, one beefy frame on wheels, easier to move into place at installation, and yeah, again, utilizing the space better than what we did with previous generations. The next slide here, you'll see that we have a self-calibrating recoating system. We've had this in the past on previous generation large frame machines, but we utilized a cantilever recoater design that was much beefier, much larger. It required us to move further in that Y direction when we were sweeping, just to get out of the way so that we weren't printing in the shadow of the blade. You'll see here that the blade is much more streamlined. It's much smaller. It actually utilizes a channel type system where I can drop the blade in and out very easily. There's nothing to unbolt, nothing to even loosen to be able to pull that recoating blade out, clean it, maintain it, and then place it right back in and get it to go right back to where it was. You'll also notice in the image to the right, those 4 blocks you see there, those are leveling motors. So we're able to calibrate much quicker than we were able to on the previous generation machine as well. So it does allow for the machine to calibrate within 15 minutes or so. And we even have a quick calibration method as well if you just want to double check that that blade is still calibrated to the resin surface. Being a resin-based system, that whole machine gets leveled to that resin level. And so it's critical in order to build accurate parts that we know where that blade is in relation to the resin. So there's leveling sensors at both ends of that recoating system that basically bounce a laser to the resin surface back up to a sensor, and we're able to measure very accurately within 20 to 30 microns where that resin surface is. And so that allows us to build very accurate layers as we basically build 2.5D cross sections of a 3-dimensional part. Again, for those of you guys that are not familiar with SLA, recoating is a critical part of building in a UV-based, resin-based system. And so to have a blade that we can calibrate very quickly and be ensured that it's very accurate, easy to clean, easy to maintain, it is critical. Next up, you'll see that we have an automatic material feed system. We utilize gravity in order to do so. Instead of having peristaltic pumps mounted to the front of the vat, we've gone to a much simpler vat design. Again, that tubing was a wear point for my production customers that are running these machines 24/7. That was something that had to be replaced on a regular basis. So going to gravity feed, less moving parts, much simpler to add resin when needed. The vat is still removable. So if you go to the next slide, you'll see the vat is actually removable. If you're familiar with large frame vats, they can be very complicated on the front. We've kind of returned into much simpler design. Really, the vat is heated, stainless steel, not a lot of surfaces to drip resin on, which, again, for those of you guys that are familiar with this process, uh, being able to keep a clean machine is important. Uh, yeah, anything that touches the resin can stay with that resin. So the elevator, the platform, the recoating blade, all that can be removed with that material, and it allows you to push in a new vat with an elevator with a new blade or recoating blade, and switch to a different resin very quickly with this machine. The machine has been entirely redesigned from the ground up, and one of the things that was on my wish list with the introduction to the machine was covering up a lot of the open gaps that you see in the build chamber. So you'll see a lot of stainless steel brush surfaces, and really that is, again, to be able to keep that surface clean and be able to control drips and when pulling parts in and out of the machine. So if you look at our previous generation machines, it was much more of an open architecture, a lot of gaps and spaces between the vat and the frame. And now we're back to rim covers, which, again, it's returning a little bit to our roots, but much cleaner design. Very high-end components. 3D Systems is very much known for building machines that last. We were never good at planned obsolescence. It's not unusual to see machines that are out there that are 20 plus years old still building great parts. And so this machine is going to be no different. It very much is designed for production, lights out, around the clock type operation with minimal interaction, minimal customer serviceable parts. There's not a lot of tuning that you have to do on a daily or weekly or even monthly basis. Really keep the machine clean, and it will be good to you and build a lot of very active parts for years to come. The user interface is all brand new as well for this machine. We used to use an Android type interface that communicated with the controller. We are now back to this. This is a monitor connected directly to the controller, Windows 10, and so you don't see the delays that you see in some of these previous generation machines because you are communicating directly with the machine. It's swivel mounted. It does have physical buttons for future robot operations if need be. But it's very intuitive, very easy to learn and understand what's going on in that interface. A lot of good information, heads up, and yeah, very simple to use. When it comes to accuracy on this machine, here's an example of a few parts. If you go to the next slide. These are parts that were printed in Acro Extreme. It's a gray multi-purpose material, but you'll see some of the dimensions on the screen there that we're picking up. You have a little over 500 micron gaps in that middle image there. You're under 500 micron gaps on the image on the right. It just kind of gives you an idea of the fidelity and the amount of detail that you can pick up with a printer. This machine, like most of our SLA printers, runs 125 micron small spot beam and then a 762 micron large spot beam. For those of you guys that work in inches, it's a 5 thou small spot and a 30 thou large spot beam. And what that gives you advantage-wise is you can cure most of the layer using the large spot and then come back in and pick up the fine detail around the outside of each layer with the small spot, and that's how we get those nice crisp corners by being able to draw with a really small beam where we need to. This slide has a little bit on it, but if you kind of get around what we're looking at here, you're basically comparing our previous generation machine, the Pro X800, with the 750 and the 750 dual laser system. And so you can see your build time improvements just based on laser power and your number of lasers. You can see that time drops down quite a bit. So when you look at throughput, you look at that Pro X800, it was taking, much more than a day, pouring on a day and a half to build this part, where when you go to even a single laser, you're getting down close to a day. When you get to the dual, you're well within that day's time. So when you look at your throughput, number of parts that you can run through these machines, we're cutting down that build time quite a bit. And these are default styles. These haven't been optimized for that particular part. I work with customers to even get more throughput out of these machines by optimizing the build parameters for their particular geometry type of parts that they're actually printing. So there are some new accessories that go with these machines. So the transfer cart, go to the next slide, is also changed a little bit. Our previous generations of transfer carts used a lever type mechanism to move up and down. We moved to a wheel that we can turn and be a little bit more precise. If you've ever tried to offload parts in a large frame machine and your floor wasn't quite level, previous generation cart would struggle a little bit in order to come into the machine low enough to get underneath the platform, but then be able to raise high enough to actually remove the platform. So this new cart is a little more streamlined in that respect. The drip tray underneath is closer to the forks that you're going to lift the platform up with, and so it's designed quite a bit better than what we've had before. You can still utilize your Ramco agitation systems if you guys have worked with that company in the past. There is a adapter kit for a lot of their tanks. I know Ramco's changed their design a lot over the years, so you'll have to double check that, but they do have 800 size tanks that can be upgraded, but it still can utilize that same design. Offload cart can actually access that tank as well, and that allows you to basically use agitation to clean the bulk of your parts, and that's traditionally been really the best way that we've found to clean SLA parts, to take the whole platform with parts still attached, place it in a machine like this that just can move the parts up and down to a solvent, something like tripropylene glycol monomethyl ether or propylene carbonate. Some of my customers even will use IPA, depending on where you're located in the world, on how much IPA you can have in a vat like this. But that really is the best way to clean these parts up. And then the right side will either be a fresh solvent or even a water rinse if you're using a water-based cleaner. Another thing that we introduced a couple years ago with this machine, and also with a new line of materials that Richard will talk a little bit more in depth on, with the introduction of AMX materials, we've gone back to more acrylate-based formulations that, in order to get the full part properties out of those materials, it requires that we use heat and UV to post-cure those parts. And so we introduced the new post-cure 1050. It is LEDs instead of fluorescent tubes, and so you get a much more consistent curing. We have LEDs on all 6 sides, including the inside of the doors, so there isn't as much of a need to move your parts, adjust, flip. You can stick them in there. There's a nice touchscreen interface with recipes already built in. You go select your resin, and there'll be a recipe there for you. It's fully tunable. You can go in and create your own recipes if you're trying to get certain properties out of the material, or you have particular part sizes, part shapes. You can actually tune those recipes to your needs. I have customers that will even use this for other 3D printing technologies out there. It kind of becomes your one-stop UV curing box at that point. This slide really shows you the advantages that you get from more control. So we have the ability to ramp up temperatures, cure with temperature, and then allow